but I thought the last time you were not comfortable with it, so I was a bit shy asking. But Barakallahu Fik, this will help me
Yeah,
to
yeah.
get back to it later on, inshallah.
Oh yeah, no problem. Yeah. Uh, where were we? Yeah, so it depends on the application dependencies. So if the application has some sensitive information, let's say this application needs to contact payment providers. So normally the charities or any of the small organization don't deal with the payments and don't deal with the facilitating or integrating with with the payment providers like Visa and Mastercard, etc. They don't do all of that. They outsource that to companies called PSPs, payment service providers, like PayPal or Work, some other company that WorldPay, something like that. So they outsource those, and then all that information would the screens that captured the data for the payments, etc. All of that would be facilitated or rendered by those organizations, but as far as the charity organization is concerned or small organization is concerned, so they need to integrate with that PSP website first. For that, you need to have credentials that recognizes the traffic coming from, let's say, XYZ charity, etc. So those kind of information you don't want to keep it in plain. So that's where the key vault comes into picture. All that information would need to be stored in the key vault. And if it is application managed credentials, etc., so we need to rotate those periodically as well. So uh, so yeah, it would be again cloud engineers responsibility to configure those keys, as well as configure the scheduling of the rotation. So if, let's say, you have a password that connects with the PSP providers and you would like to rotate that password every 3 months or 6 months, so you will have a task created for that. First is to configure secrets in the key vault, and then you will have tasks to auto rotate the credentials based on some schedule every 3 months or 6 months. So those kind of things would again be a responsibility of the cloud engineers. And again, on the database side, if it is using SQL or NoSQL database, whatever type of the database that the applications need, we would have to create those. And again, all these details would be part of the tickets that are assigned to the cloud engineers. And first, we need to create the SQL database, and also again we need to have a replica. Normally replicas are in a different AZ, so because it's all is done in a single region, let's say in London West, single region, but within that you will have multiple data centers, AZs. So it is best practice to keep the databases in different AZs. It's even better if you keep multiple regions. So let's say you have Ireland and UK region, then you can keep the backup in Ireland, but that's going to cost more because you are using two regions. But most of the small companies, they tend to keep everything in a single region, but they try to distribute their workload in multiple AZs because data centers are completely independent. Unless there is a catastrophic event happens UK wide, then there won't be any chance of losing the data. So yeah, again, you'll have to configure multiple AZs and keep the main database in one single AZ, and the different AZ you keep the replica, and then also you set up the replication factors, how frequently you would like the data to be replicated and all of that. So again, this will result in multiple tasks for the cloud engineers to set up that SQL database. And Redis is like an optional kind of in-memory database. If the application is using it, again, the responsibility of the cloud engineers to set up the Redis cluster, how many instances are running, which one is the main, which one is the secondary within the cluster. All of that would need to be created by the cloud engineers. I can create the task if you need, Abashir, a more granular task for you to work on it if you are interested. But yeah, those are the kind of tasks that would be needed to expose these APIs. Once that is done, yeah, the traffic, either mobile application or web application will go through the DNS, and then instead of going this route, they will go this route because we have /API on the domain name, and we will use the domain based routing to route the traffic to application gateway, and then APIM will take care of the authorization of those requests and forward the request to the application server. So these are the containers built in a programming language. So those containers will have all this health monitoring and performance monitoring and best practices, etc. All of those would be configured these tools, and then all the dependencies that are there for that application, like secret keys or databases or in-memory cache or application config, etc. All of that need to be configured. So that's the one API model where we'll have containers running on app service. But if it is a more complex requirement, then we can perhaps use container apps like or you can use the Kubernetes to orchestrate the communication and the service discovery between application. But if it is a simple one, app service is probably the better one because it's a single container. You can use a single environment with multiple instances of that container to expose the API.
For the tool, the app service is better, is it? When given a choice.
Yeah. So because if we keep both of them in two different AZs, then if something goes down, and then the other one can take care of the traffic, and then the load balancing will be happening at the APIM level, whether it needs to go to that instance or this instance. Both of them would be running the single container. Yep. So that's the kind of API model. And another one these days is popular is the function app. So I will just quickly explain function app. So in this case, let's make requirements, theoretical requirements, like whenever an individual donates money on the charity application. Let's say these applications write the transactional data, how much money is donated and what is the purpose of that, and the date of all of that would be stored. But the individual's details, like the name and the address and his phone number and contacts, let's assume they're all stored in a NoSQL database like a MongoDB in a document like structure in JSON. So let's assume it's stored there, and then there is a admin app from the charity organization where the workers working at the charity would like to see the individual details that have donated money in the last 1 month or so, and then that admin app would again invoke an API. That API can be provisioned through a function app because it's a very simple API. You have the data related to the individual's details and individual's address and mobile number and the phone number and the email ID, etc. So what we'll do is we'll create a new function app. Again, the function app definition, either it's happening in Node.js application or Java or Python, etc. All of that is up to the developer to decide, and they will create the application, function app application, and give it to cloud engineers. The job of the cloud engineers is to provision the function app and ensure the function app is again multi-AZ within the single region, so that one function app goes down, we have another instance running on a different AZ. That we will have to configure on the function app, and then function app connectivity with the Cosmos DB. Again, Cosmos DB, again responsibility of provisioning Cosmos DB, configuring the MongoDB API level so that the application can connect to the Cosmos DB and store the information or fetch the information from the MongoDB table document table, and then send it back to the, let's say, admin user who is interested in list of individuals who donated. So again, that's another kind of model where we will use the application gateway to have the WAF and DDoS protection, and then APIM to route, kind of load balance multiple instances of the same function app, and then that will connect to a database. Again, Azure Monitor can be connected to the function app and insights as well. So all of these utility that Azure provides can be configured with the function app, and that's again some of the task they're normally assigned to the cloud engineers. Yep. Any questions on the API side before we go to the different application on this side, Abhishek?
No, that's fine. You explain very well, mashallah. Barakallah.
Alhamdulillah. So that's the kind of so we have a static single page application, and then we have APIs. So any static application wants to fetch some information from database or record something in the database, again they would use the APIs, and then we have all that configured here. So we have done both of those. So let's take another use case where have you heard about WordPress? So where the WordPress is like a tool that enables building web applications. So let's take most of the. It is very cheap way to a cheaper way to build web application, basically, rather than building a custom single page application using React or Angular. Rather than doing that, so WordPress is more economical if you want to build a web application. So let's take an example of how do we deploy the WordPress web application in Azure tenant. So again, you will have an Azure tenant, and the entry point under your subscription entry point will again be DNS. So here the users is web application users are mobile application browser users, not the app users. The APIs was the app users. So mobile application can use the same like Safari or Chrome browsers, or from the web users. When they access a website that is hosted on WordPress, then we can route the traffic to same CloudFront. CloudFront provides the DDoS and WAF protection. Again, these we will have to configure. And from then onwards, based on the domain routing or IP routing, we can forward the request to the load balancer. Load balancer here is going to be internal load balancer. It's not accessible from the outside of the tenant, Azure tenant. So we create a load balancer, private load balancer, internal load balancer, and then that we will route the target. We will register the target as a Azure VM scale set. So we will have multiple scales, multiple VMs within a single scale set, like a target, let's say 5 VMs or 2 VMs, something like that. So yeah, the responsibility of the cloud engineer from a task point of view is to route the traffic that is coming on that website. Let's assume this is going to be a different domain rather than the ones that we use in that example. Let's say use this a different domain for same organization or different organization, that we will have to route through front door distribution to a load balancer, internal load balancer. And when we create the load balancer, normally they are public. So you need to ensure this is not public. This load balancer is not public. It's only accessible from the front door. It needs to be restricted. It needs to be restricted from public access. Those again would be tasks for cloud engineers. And then register a target as a VM scale set. So again, we'll have to create a Azure VM scale set, which will have multiple VMs configured. And then each VM, we will have to provision those VMs and include those in the scale set definition. What type of machine image that we are doing, what type of memory, CPU that is needed for that VM, etc. So we will provision those VMs either using the marketplace, or manually we will have to install WordPress in these VMs when once the VMs are provisioned. So that's where we will use a concept called Bastion service. So the Bastion of public IP allows allows cloud engineers to directly access the VMs, because public they can access the website hosted via DNS, but cloud engineers need access to the VMs, the physical machines. They can access the folders within that VM, access the internal program files, if it is a Windows machine or if it is Linux one, internal folder structure, operating system, etc. So for that, we will have to configure a Bastion public IP first. Again, that's the task for cloud engineers to create a Bastion public IP within the virtual network, within the Azure tenant, and then also provision a Azure Bastion server. So these are all provided by the Azure. So you first create a Bastion IP and the Bastion server. So once that is done, what you can do is using your local computer, you first log into using the Bastion public IP, you log into the Azure Bastion Windows server. So it's like a remote desktop into that server. So once that you've done the remote desktop, from there you create an SSH 22 port, you will create an SSH to connect to these virtual machines, so that you can either install the required WordPress software, or you can enhance or upgrade the security patches that are available on those VMs, or having like a regular kind of patch maintenance of those VMs, etc. So all those things you can do by directly connecting to Bastion server and SSH into these virtual machines. So they again, if you are going to replicate this in your local Azure tenant, you can create these, and then using your Windows machine, you can remote desktop to Azure Bastion, and then from then you can use SSH to connect to VMs and install WordPress, etc. All of that task you can create yourself. So that's gonna be Azure VM set, and then our WordPress sites would be running, would be hosted, let's say WordPress file. The package WordPress website can be hosted in, let's say, Azure file storage. You can host it there, or you can host it in Azure storage account, and then virtual machines WordPress would access that, and then whenever the request comes, the website would be rendered according to the template used on the WordPress. So those we can configure, and then there is another concept of accessing these dependencies. So here we access directly from that service. That's one way. You can access these dependencies like databases, MySQL database, or Redis in-memory cache, or key vault, etc. All of that you can use it via private endpoint. So rather than directly accessing from Azure skill set, you'll create a new kind of subnet with network security groups. So create that new subnet within your virtual network and create private endpoint. So the benefit of private endpoint is these dependent resources can only be accessed via the private endpoint, and your traffic resides on the Azure backbone rather than traversing outside of that. So you can have private endpoints to access this. It's again nice to have, or you can directly let your VM machines to directly connect to databases, etc. But it's nice to have your private links, private endpoints, and private endpoint will have definition what is the target IP address for the Redis and MySQL and Key Vault, etc. And another dependency is app config. App config is mainly used to store feature flags, something. Feature flags, what I mean by that is, let's say you're launching some new functionality on 1st of Jan, and you already deployed it, but you don't want users to access that yet until the 1st of Jan happens. So those kind of application configurations you can configure in app config. If the application needs it, then again the cloud architects and solution architects would create respective tasks for cloud engineers to create app config, and also ask them to enter what type of configuration is needed within that. So it will all be in the ticket required. And then we will also need a NAT gateway to download security patches or anything that VMs need to connect. Whenever the VMs need to connect to internet, since the VMs directly cannot connect to the internet and download some security patch from the internet, so that's where we need a NAT gateway. So again, it's responsibility of the cloud engineers to configure NAT gateway and link that with Azure VM machines, virtual machines, and then we would need a NAT IP address, public IP address. This is the public IP. So we'll have to have, because every request that is going need to have public IP, because when the target of the website. Let's say we are downloading something from the Google would require where the request is coming from. That's where the request needs to have a public IP assigned. So that's where we will have to assign a public IP. Then only NAT gateway would route the traffic to the internet. So that's, let's say, any website on internet. So yeah, we will have to configure NAT gateway and link that with VM scale set, and then configure a public IP, give it to the NAT gateway, and then so that and test. From a cloud engineer's point of view, you can connect to the Azure Bastion as a remote desktop, and then SSH into VM, and then let's say ping google.com. Then it should be able to hit the internet and then show the response on the terminal. So that's the way normally security patches are upgraded by the cloud engineers. So that's again another model of web application, hosting web application. Yeah, I think, yeah, any questions so far, Abhishek? Otherwise, we can go to non-web application related models.
It's fine. It's fine.
Yep.
Alhamdulillah. Yeah.
Yeah, good. Alhamdulillah. So let's look at this last one, and then we can go into some other if you have time. So this model is normally within the web application these days, where the front end and the back end are separated. So when we're looking at this website, the front end is static, means it is all there and cached by the CDN. CDN in our case is the front door. It cache, and same request is coming for, let's say, events. It would cache that, but the dynamic information within that, the one that is displayed here, is coming from API. So those are kind of separate. Backend and front end are they're referred as. So the front end is served by static content here, and the backend is served by the APIs. But there are some applications where front end and back end are bundled together into the single app, like Java web applications, where that application also does the front end as well as the back end. So both static as well as dynamic content is served from the same containers. So in that case, what we can do, like a Spring Boot web application, for an example. So in that case, what we would need is we need the caching capabilities of the front door. So we app gateway can directly connect to a DNS. It can take the traffic like it's happening here for the API. But here, these application also serving the static content. So we need the static content to be cached here so that the repeated requests coming from different users can be served rather than here. So when, let's say, some static content HTML page is requested by, let's say, 100 users, only first user needs to go and get that data, and the second user onwards, this front door doesn't send the request here, it serves itself because it has the data. So that purposes we need a front door. We will configure DNS again, front door, and we will add the WAF and DDoS protection. And then here API gateway, we will make it as an internal API gateway, application gateway. So that application gateway will route the traffic to, again, app services or container apps or any other mechanism. It could be a function app as well, any other resource that Azure provides, or Kubernetes services, etc. It could be anything. So that will take the traffic from application gateway. Again, these application gateway will have similar kind of dependencies of the databases, or similar, may need access to external world. Again, if that is the case, we need to configure a NAT gateway and a public API. Yeah, this is another model of a web application normally used within the industry. So for small organizations, brother. Yeah, so those are the kind of web application models. But there are other, normally in an organization, normally we will have different types of requests that cloud engineers that I have seen fulfill those requests. So for example, setting up virtual desktop for remote users. So let's say most of the companies, they outsource the work to either Philippines or India, etc., where the developers from those countries connect to your infrastructure and then work. So in those cases, it's not feasible to give like a internal company laptops to them. So what they do is they create these Azure virtual desktops. So where they use their own personal laptops, or they outsource to some company, big company, let's say Infosys or TCS, and those individuals log into Azure virtual desktop, and then once they log in, you will have access to the VPN, the company's VPN, and they can carry out all these tasks. So those kind of tasks would also be created by cloud architects for the cloud engineers to create Azure desktop, enable remote desktop, and then ensure they all fall under the same VPN as the company organization's VPN. So that's one other kind of requirement that normally cloud engineers work. Another one would be VPN tunneling and VPN peering. So that's again from a networking and infrastructure point of view. Most of the organizations have their Microsoft 365 account and then Azure account, two different things. Microsoft 365 enables them to have this Outlook and SharePoint, and then the desktop teams and all those things to enable the organization to work. So whoever is working within this organization workforce will use that Microsoft 365 environment. And then you will have the Azure one, which is mainly for the hosting the infrastructure. So you will have tasks related to integrating Microsoft 365 with Azure tenant. In terms of moving files from Microsoft 365, SharePoint is a Microsoft 365 file hosting platform. And then within Azure, you have like storage accounts and file storage, blob storage and file storage, etc. So all of that you need to either move data from there into Azure tenant or move data from Azure tenant back into Microsoft 365. And if it has the internal what you call data centers, private cloud, if the company has private cloud, then we need to work on the VPN peering and VPN tunneling and all those tasks related to the enabling VPN connectivity, like enabling VPC flow logs or what other thing I can think of. Yeah, enable basically you connect to one VPN on the private cloud or on the local data center, and then we will have to let the traffic come in from there. So we basically have as another entry gate here, rather than on the DNS being here, we will have another VPN gateway that will allow traffic coming in from other other external private cloud or data center come into this. So that's another kind of list kind of task that I've seen Abhishek in the real world. Other things that I can think of is yeah, another main thing is building the CI/CD pipelines. So the small organization normally use Azure DevOps to build the CI/CD pipelines where the developers commit their code into a Git, either GitHub or GitLab, and then Azure CI/CD pipeline DevOps will pick that up, package it, and push it to a container registry. So again, that's one of the key areas that cloud architects work. Yeah, I think that's pretty much kind of generic different set of models, Abhishek, in the industry, especially when we look at in the context of building a new charity organization's infrastructure.
Okay.
Any questions?
Which is the most popular model that then out of these three? Like obviously the mobile one, many people use. But out of these two, which is the popular one that normally a lot of people use, maybe from your experience?
This one. So this you will have a storage account where the static content is being rendered, or you can have static content can be rendered from a Nginx server as well. So Nginx is running on the VM, but normally the most of the companies these days follow this pattern where you have CloudFront for the static content and the APIs for the dynamic content. So this half of the diagram is most popular in my opinion, where you have a separate front-end application and then separate back-end APIs, and the APIs can be reused by mobile apps, as well as the web browsers. So both can use the same APIs, and the mobile apps front end would be hosted within the iOS App Store or Android. So there is no need for the Azure to host that. Is hosted by the platform itself, but the content that is needed, static content is part of that package that's hosted on the Android or on the iOS, but the dynamic content like a list of events, a list of charity projects that are doing, etc. All of that is coming from a database, and those are all rendered, facilitated through an API.
Okay.
Yeah, if we need, brother, I can probably put together a list of tasks required for each of these model if you're interested, but you can probably start working on some of these as a practice, because the most important thing for the first job is to play a story, basically what you've done, what are your responsibility, what are the tasks that you've done, etc. So then based on your initial response to what you worked on, let's say you worked on application gateway configuration or WAF configuration or DDoS protection, etc., then the interview would ask you more granular questions in that area.
Yes. Yes, please. You know, anything I could get a bit of experience from this, I would appreciate.
Sure, inshallah. Yeah, I'll try to write it down a list of tasks for each of these resources. How do we provision? How do we configure? How do we integrate with other resources? Yeah, inshallah, I will try to write it down. Hopefully by next week or two, inshallah.
Inshallah. Barakallahu fi. Thank you very much for that. Because on studying or when you watch and work experiences, they're two different things, to be honest. But
Yes.
once you start doing it, it makes kind of, it's like a handshake. You know, okay, this is this. But normally, like, it's just daunting when you it's something new that you starting on this field.
Yeah, that is true. So in my experience, work experience, you'll have various different tasks that are coming in, but good thing is you will have the help needed, and the ticket or the Jira story that is assigned to you would have all the detailed steps that are needed. If you have any questions, you can go back to Cloud Architects. I myself, I'm not a cloud architect, but I work mainly as a solution architect. My job is mainly to engineer the requirements that's coming from the business, and then I need to know, I need to build a diagram like this, build high level kind of application infrastructure kind of architecture overview, high level data architecture, high level application architecture, high level integration architecture. So all of this I work on very high level, and then the cloud architects will take this as an input. So then they work on more granular level designs, how what kind of WAF policies we will be creating, and what kind of tunneling, VPN tunneling we will enable that, and how many subnets, how many what do you call AZs we will be using, etc. So all of that would be part from coming from the cloud architects, and they will create like in-depth details on that ticket and then hand it over to the cloud architects. So cloud architect mainly work on the Terraform, so they don't normally access it via console. When they access it via console, it's mainly for the POC purposes. So if let's say the company hasn't done anything so far using the cloud front door, and then we're hosting a first time a static website on the front door, then we will use the console to create that kind of POC. But once that is done, individuals move to Terraform. And so, yeah, it is vital that you know Terraform if you're working on Azure Estate. But if you're working on AWS, the cloud formation is rather used more frequently there rather than the Terraform.
Okay.
Yeah.
I'll try to look into Terraform as well because I've seen it when we were studying this as well, and I've never, went on or just, browse around it. I can watch some
Terraform
videos
is
and see.
absolute must for the cloud engineers. Yeah.
Oh yeah.
Yeah.
Okay.
Yeah. So once you're comfortable building different types of models, you can access the different types of Azure architecture. So there's all types of Azure architecture, like thousand most frequently used and the industry standard models are there. So they keep on updating this page. So keep an eye on and that if you need some if you're working on that, how best to use the that particular resource, you can search it and you'll get different types of architecture that will be useful when you're practicing. If you want to enhance these kind of models and add more functionality and get rid of the app service and build a container apps rather, which is more complicated, or even better Kubernetes to serve the containers, etc. Yeah, you can gradually enhance these models to build more complicated stuff.
Sure.
Sure. Do we have Ustad Irfan? Let me stop sharing. Stop sharing. Yeah, I think that's all from my side. Ustad Irfan, do we have anything? I'm not sure if you're still there. I think he may have gone. Yep. Any questions, Abhishek, before we wrap up?
I know it's mashallah is you explain very well. Like I know like when once well the good thing about this exercise I can look into and then we can see with this charity work
Yeah.
the good thing about this field is not it's not like they give you work or with such like you always find help like and you can go to as that page you showed me the Azure architecture of everything, so you can know where to help templates or for any direction. You can
Yeah.
ask someone or go and see how to open it up or how to configure something whenever you're stuck. So it's a little bit different from other fields, but unless you start, I can have really either questions that are nonsensical at the moment, but once I start doing it, then for me it will make more sense.
Alhamdulillah, alhamdulillah. Yeah, that sounds good. Yeah, inshallah. What I will do, brother, I will try to put together list of tasks for each of these resources and like what type of WAF policy we need to configure and basically kind of